All right, next part asks us how can you find the inverse of a function? Real quick, just a reminder from previous classes that inverse, there's a notation for inverse of a function, f to the negative 1. So that's, whenever you see that notation, like you do down here, that means the inverse of f. So to find an inverse function, goes back to the beginning of the notes, we talked about you have to switch x and y, and then solve for the new y. So let's look at an example on the next page, number 3. Now, you don't see a y there, but remember, f of x is just a different way of representing y when it's a function, so a function of x. So we're going to say this is y equals 5x minus 2. We're going to switch x equals 5y minus 2. So switch the x and y. Then all we have to do is solve for the new y. So we're going to add 2 to both sides and then divide by 5. So y equals 1/5 x plus 2/5. So we can write this with the notation the inverse of f, that's our original function, equals 1/5 x plus 2/5. You could leave it as x plus 2 divided by 5, but this is a linear function. Generally, we're not going to write it that way. We're going to have it in slope-intercept form, but it would be acceptable. I wouldn't mark off. Now, take a look here. If you notice, the slope of our first line and the slope of the inverse are reciprocals of each other. All right, we're switching x and y like we did in our graphs. Well, that's going to be switching our slope as well, right? Switching the x and y in our slope formula, so it makes it a reciprocal.